Hello friends, welcome. Today we are going to take a look at how do we solve question number 8 in our CBSE Class 10 test. Now, what is question number 8? Prove that the points 3, 0, 6, 4 and -1, 3 are the vertices of a right-angled isosceles triangle. So when you get a question like this, the first thing that we want to do is that isosceles triangle is such a triangle where two of the sides are equal, two of the three sides are equal. So we have to prove that these coordinates or these points are basically the vertices of a right angle triangle. So we have drawn a right angle triangle. So now we don't know if this is A, this is B, this is C. We don't know which two sides because all we have been given the coordinates of the point A, B and C. But we do know that any right angle triangle will look like this, and if any two of the sides are equal, these two sides need to be equal because hypotenuse is the longest side. Now we don't know which is A, which is B, which is C. So we do know that any two sides, AB, BC and AC, we know that of the three, any two of them will be equal, and we also have to prove that it is a right angle triangle. So the way we have to prove that is we have to find out the length of each one of these sides and then find out if and which of the two are equal. Also, how can we prove that it is the three lengths are part of a right angle triangle? Well, we know that Pythagoras theorem states that hypotenuse square is equal to one side square plus the other side square. Right? So we know from Pythagoras theorem that hypotenuse square is equal to base square plus altitude square. So now with that in mind, let's take a look at how can we go ahead and solve this question. So say A, B and C are the three vertices of a triangle, right? Now using the distance formula, we can find out distance between any 2 points. So in general, if we have point x1, y1 and another point x2, y2, from distance formula we know that the distance d is, we can find out the distance by using this formula, which is square root of x2 minus x1 squared plus y2 minus y1 squared. We have learned about distance formula earlier. Now we know the coordinates, so we can find out AB squared. In other words, if D equals this, so from here we can say then D squared, we are just simply squaring this, will be x2 minus x1 squared plus y2 minus y1 square, right? Actually y2 minus y1 square. So AB square, because we are assuming if this point is A, this is B, this is C, so AB will be 6 minus 3 square, 6 minus 3 square plus 4 minus 0 square. So AB square is going to be like this. So we just simply solve it and we find AB square is 25. So at this point we could have done AB equals square root of 25 or 5. The reason we are leaving it as AB square, because again keep in mind for Pythagoras theorem we want to actually get the squares, right? So let's similarly find out what is BC square and AC square. Simply using the same distance formula we can find out. So AB square is 25. We note that BC square is 50 and AC square is 25. So now that we understand this, we can clearly say therefore AB square is 25, which is same as AC square. So AB equals AC. So we know the triangle ABC is an isosceles triangle because we have two sides of the triangle equal. Now in order for it to be a right angle triangle, we also note that AB square plus AC square, which is 25 plus 25 is equal to 50. Now what is 50? When we looked at each of these sides, we realized that BC square is 50. So what we have is AB square plus AC square is 25 plus 25, which is 50, which is same as BC square. So clearly we know that this is a right angle triangle because we can say from Pythagoras theorem, we know that if sum of squares of two sides of a triangle, they are equal to the square of the third side, then it is a right angle triangle. So we have proved that AB is equal to AC, and we have also proved that, so this is one, we have proved this, and we have also proved that AB square plus AC square is equal to BC square. So from 1 and 2 we can absolutely say that indeed these coordinates, this, and this, are vertices of a right angle, because this is Pythagoras theorem. This proves the right angle triangle, equation number 2, and isosceles triangle, because equation 1 clearly proves they are also isosceles triangle. So this is how we solve question number 8.